Hey everybody, how are we doing? I am pretty much out of coffee. We've had all the coffee today, so it's time for statistics and time for data. So if you're here, let me know in the chat. I'm going to put a timestamp. Mubot is finally awake, so make sure to talk in the chat. Let's go off the top chat. We're currently on regular chat right now, and so we've got it. Let's get in here. Don't go off the screen though. There's not a window here that traps me in this world, but let's see what people are saying. We got Mubot awake. Hey, Abigail, great to see her. You had questions, right? Working with the stuff. I think I know. Let me go grab that from the Discord. Abigail, let's throw out 100 points. Thank you for being here, Abigail. Sorry I got started 2 minutes late. We were finalizing some projects. So I just this down. It's almost going. Oh. Are you free later? Okay, let's go take a look, Abigail, at the 320 stuff. And so I think I see the issue. Okay, you have an RMD, intro to R to RMD, and you have line 125. Can you send me your file, Abigail? Let me message you right here. Can you send me your file? Okay, as long as you're okay with me sending your file, and we were covering it yesterday. So Abigail, if you can send me the file, I just messaged you. You can drag drop the file into there. And I'm going to open up the file, and we're going to take a look at it, and we're going to fix it live. As long as you're okay with that, kind of look at it together. And the biggest thing, Abigail, you're doing everything exactly right by running into errors because, and then you just ask for help. You just say, it doesn't work. What's going on? And then we say, oh, this is the issue. You say, oh, that's because I was just meeting with Adam Spanbauer, and he's shown me so many things. Like, he's like, oh, did you know you can do this or this? And I'm like, whoa, what? Like, there's so many cool things. Awesome, Abigail. I just messaged you on Discord, so you'll see the message there. And that's why I love Discord. It's like so easy when someone just sends me a file, just be like, oh, here's the file. You don't have to worry about like opening an email, typing in my email address. Like if I message you, it's just like instant message, like click my name, drop file in, and I have file. So we should have the file here in a second. We'll open it up. We'll talk about some BAS. So let's take the timestamp here. We'll be about 4 minutes and 10 seconds in, probably. BAS 320 activity 1/graphics help, and we'll get to see the cool graphics here again, and we'll talk about some issues. So last night we did activity 1, and we did some kind of like neat things with it. Hey James, good to see you. I have a question about activity. How to join the Discord? Mubot's going to put that Discord information in the chat right here. And you can also ask the activity, can you resend me a message? Of course. There you go. I just resent you a message right there, so you should see me pop up like in your corner right there on the Discord saying like, Brian Stevens sent you the message right there, and Mubot put the information for the Discord. James, if you let me know any questions, you can ask about the activity right now. This is for 320, right? So you can ask about the activity, anything you want to know. Make sure I have everything closed down and ready to go over here. What do I got? I got that. Oh, we got 475 activity coming up, or 475 a group project coming up here soon. Okay, perfect, Abigail says. We got this. Yeah, we'll start up the stuff. But James, feel free to ask whatever you're wondering about. We can start working on that. We've got all of our volumes up. Let me put this here, put the headphones a little bit higher. There we go. I might just buy some AirPods. I might just say, why not? Should Brian buy AirPods? Should Brian just be like, wired headphones are good, but my fiance's AirPods are really, really nice. I actually bought her the AirPods, and then I steal them sometimes. And I'm like, how do I ask in the Discord? You can ask here too if you'd like. If you've joined up the Discord, so if you've gone through the authorization and all that good stuff right there, make sure you do the authorization. Make sure to choose a role. You can message my name. How do I save and send it? Here, I'll go and show that right now. Let's go talk about that. So go to File and Save As right here. I don't have a file open. But go to File, Save As. Does that make sense, Abigail? Go to File, Save As. And once you go to File, Save As, it'll start to save somewhere on your computer. I don't have something open, but if I did, 2 seconds right here. Like pretend I have a new file right here. So we'll go to our Markdown. Let's call it random file. We're just going to create a random file right here. And then once you have this, go to File, Save As. And so you'll save the file on your computer. And once you have the file saved on your computer, go over here to Discord and then just drag drop the file, like go to the location on your computer. And it looks like you've done it. Abigail, do I have your permission? Put a capital YES to just show this file on my computer right here. Just want to double check with you. As long as you're okay with me showing it, I'll go through and do the debug. Or you say, do it on Discord instead. Your call. Once again, 100% fine. Which whatever you choose. Lost Tunes, just whatever you're okay with. You're okay with me showing the file here on the stream. Yes, there we go. I was 99% certain, but I always like to check if someone sends me something like, are you okay with me showing this? And it's really a great opportunity for us to debug this. So here we go. We're going to open it. I already have my files associating to open inside of R. So you can see right here that it opens and we have the activity. Now this is an R Markdown file. One thing you can do with Markdown files is you can click the button right here and view it as a Word document. And what's really nice about this is if you want to bold the text, you can just highlight text and click bold like you're in Microsoft Word. If you want to underline, do all those things right here. Now, if you go out of the Markdown editor, this is just an editor to like see things. If you go out of the Markdown editor, it's going to look all crazy. Like, whoa, that's not kind of code that's like LaTeX code, or it's like, it's telling Microsoft Word to do those things. So don't worry about that. If you want, you can do it here, or you can always do it when you go back to Microsoft Word. Just kind of a quick aside on that. I think your issue was on line 145 or so, I think I saw. So we're going to go down to line 145 or so. Might need to go back. And I remember seeing it. Where's the graphic? On the activity for question 1, my log10 function wasn't working. We'll try it here in a second, James. You got it. I ended up deleting it. Oh, no. Do you want me to show how to do it? I'm going to show how to do it then. That's totally fine. Let's show how to do it. So here's what I'm going to do is I'm going to go back in and James will look at that problem next. James, thank you so much. Let's throw some points here. James, I appreciate you being here and we will definitely be doing that. So what I'm going to do, Abigail, is I'm going to take this right here. So follow along with these steps. I'm doing very slowly. I am taking and copying the code. Does this make sense, Abigail? This is too big for me to post right here, but I copied the code. Are you following along right now? That I've copied the code. Like all I did was go into Discord, highlight all this code, and hit Control or Command C. Like, are we good on that? So this is now stored in my copy right now inside of, cool. Good, we got that. So that's been copied to my clipboard. Go to the Discord, copy that code. It's one of the great things on Discord too, is we can like share larger codes. So now that we have that code copied, here's what we're gonna do. We're gonna go back inside, and let's go to the very end of this. And thank you, Adam Spanbauer, doing some huge help. We're going to go down here to the very bottom of the document. So I'm at the very bottom. I'm just going to pause here, make sure you're at the very bottom. You can just do some extra blank spaces like I'm doing. It just tells you the line number. That's what it means. So when someone can say, oh, go to line 173. So I'm just doing extra spaces. What I'm going to hit right now is this button. This has a C and a plus, which means add chunk or insert chunk. I think of it as plus chunk. What is a chunk? Chunk is where we do coding. So why is there different options? Well, you can do Bash. I don't even really understand Bash. Looks like C prompt to me. There's D3, there's Python, there's RCPP, there's SQL, there's Stan. I Stan R. There you go. So R chunks are what we're going to add in. So in R chunks, what coding language do you think we'll be programming in? Just take a wild guess for 20 points. What programming language do you think we'll be coding in if we put in an R chunk, which is really the only ones we'll use in this class? But what programming language do you think we'll be using with R chunks? What programming language do you think we'll be using with R chunks? So this is going to put a coding chunk for us to do code inside of. What coding language might an R chunk have us coding in? Probably. So we can probably, if we put an R chunk, that's going to allow us to do code in R. There we go. Now, if you notice, there's already a chunk over here. Like, well, so it'll be R code. I'll throw you 20 points right there. This is, yep, coding, and that's the coding language. Like, imagine this is like saying speak German, and then this one down here says speak English. You see how it has Bash right there? So this tells the computer what language it's in, and you see how they have that starter right there. So this would be a Python chunk. This would be a Bash chunk. This would be an R chunk. But if you notice throughout our class, all the chunks are kind of R chunks. Like you'll see R chunks because we code in R. It's just that there's the ability to do other things. It's kind of like if you're taking class at UT, you'll probably hear English a lot, but you can speak other languages. You speak German, you speak Italian, you speak French, Chinese. You can speak any other language, but you're probably going to hear a lot of English probably. And but there's other languages that the coding program can understand right here, but we don't really use those. So I'm just going to delete those. Now, what you'll notice here is that there's a slightly different color. Now, here's the things you want to be careful about. This backtick, 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 then curly brackets R calls the chunk. That says start chunk here. This backtick, backtick, backtick ends the chunk. So if I delete one backtick, I destroy the chunk. This chunk no longer ends. Do you notice how the chunk keeps going? You need 3 backticks in a row to end the chunk. So notice how this doesn't stop the chunk. The chunk is just where we code. So you have to be very, very careful, especially when building things, to not destroy your chunks. And it'll end where the 3 backticks are. These are backticks. They're on the far end of your keyboard here, next to underneath the escape key over here on my purple keyboard. And that starts and ends the chunk. If you don't start the chunk either, we don't do that. If you don't start the chunk, you see no chunk options. So what you should see, if everything's right, is on a chunk, you should see the chunk settings. And we don't need to go in detail on this now, but that's the settings of this chunk. You can run all chunks above, or you can run the current chunk. So this is just like options for the chunk. So what are we going to do? I like to make a little space here just to kind of have room to breathe. And then we're just going to paste the code in. How are we doing, Abigail, on this? It's getting really mad at me. We'll see what it's really mad about here in a second. I thought I copy pasted this directly from yesterday. It's mad about something. It's really mad. We'll take a look right here. It might be because I reset R and it might be saying dplyr R is not on. Too many arguments in call to layout. Unmatched argument plot. Ooh, it's mad. I hope yours isn't mad like mine. Too many arguments? I directly copy pasted this yesterday. So you should see neat bright colors. Hopefully yours is not going as mad as mine. We'll find out if this breaks or not. Worked yesterday. So this first thing right here is going to install Plotly. Now, this is like downloading a video game. So when you download a video game, you only download a video game once. Mine has an error for the fig at the end. Oh, let's take a look. So tell me this, run this line of code right here, just this one line. And does that run? Did this run? Now, and these aren't errors. These are just like it's loading packages. So when you ran line 178 like me, does this load, yes or no? Like just only go to line 178 and be anywhere on it and hit Control or Command Enter to run that one line. It's already loaded, so it won't do it a second time. But just run this one line of code. Boop. It didn't run. Okay, so now run this line of code right here. If that didn't run, it's because you don't have the Plotly package. So go to install Plotly, and that will install the Plotly. Didn't run, go to 177 and install it. So I'm just reinstalling it right here. Mine says it won't install because it's already in use. So it should say like going to CRAN server. The CRAN server is a repository where our packages are stored. So go to 177, this line right here, and just run this one line of code right here, which will install the packages. That should run. And mine won't run because I'm currently using Plotly. So let me know if that works right there. And if that works, you should now be able to run line 178. How's everything looking on that? Is that a good to go? Yes or no? We'll see right here. It runs, awesome, and then 178 runs, I'm assuming now. So now that Plotly is installed, 178 should run. So with 178 running, now here's the interesting thing. 179 is not going to run, and that's all right. Because 179 is using the customer data frame. And if you notice, the global environment up there has nothing in it. So the reason my line 179 won't run right here is because I don't have the customer data frame. You see, it says cust not found because it's not up here in the brain. But what button do you think I should click? Settings on this current chunk, run all chunks above, or run this current chunk. If I want to get the data frames loaded, do you think I should run this, change the settings on this chunk, run all the chunks above, or run the current chunk? What do you think I should do if I want to? So think about what would possibly do it. Button 1, 2, or 3 I could click, and that would load in the data that was done above. There's some hints right there. What do you think we should do? Throw some more points right here. Do you think we should click button 1, 2, or 3 to load the data that's above? Run above, exactly. We're going to run all current chunks above, and you notice it loaded it all in. Great job. You've got the subset there with custd. You've got the customer data frame. You've got your values of X stored. So it just ran everything above. It just said run all the current chunks above. So now we should see cust up there. Now we're just going to run line 179. That creates our X values, and we're going to run line 180. And I actually think it was mad about errors because of the X val and Y values. Now, one thing you might want to do is have your window a little bit wider. So make sure, how are we doing right here, Abigail? Did line 179 and 180 run? Did both those lines run? Make sure you have stored into here those values. And did line 179 and 180 run? How are we on that? To run all chunks above, press this button right there. I'll pause on that. So that'll run all chunks above. The second middle button right there is run all chunks above. It's got like a down arrow going to like down to the current chunk. That's what that stands for, is like everything above will be ran to where you're currently at. So all the code above is ran. That's what that button does. It's like, oh, let me just run everything above. Boop. Because if you're like right here and you're like, oh, I got to run all this up here, you just go, let me just run all that up there. You go, boop, and it runs everything. You got even a bar chart right there. How are we doing? And then slow me down or ask questions. That's the exact thing to do. More points right here. Just keep saying, wait, how'd you do this? It says it's already executing. Does it have like does it have like a red thing right here? You might have an install up above. Well, it shouldn't. Did it run everything? Does your screen look like mine? How's everything looking? Do you have these? Tell me how everything's going right here. We sound like we look like we're doing all right. How are we doing? And I will say this. Afterwards, delete this right here. Delete the install packages or add a comment before it. It ran my first two like 117. Exactly. Yep. Perfect. So I think you're good. The command prompt looks good right now. I would comment out that install.packages. You can't knit those, and we don't need to run them again. So I would comment that out so it's not used anymore because we don't need to install it a second time. Run line 179, 178. Do those run, yes or no? Did 179, 180 run? Like these two lines right here, you can actually highlight both. How are you doing on both those running? Do both of those lines of code run? And then you should see those values appear up there. How are we doing on that? Yes or no? Because we're almost there. And great work. Good practice. I think so. Good. Okay, make this window a little bit bigger right here. So we're not going into too much detail on what this code does, but it's creating the object fig. Does that make sense? And it's using a plotly function. We'll kind of stop at that because this is a function because of this parentheses right here. We're not going to talk about dplyr or pipes right now, but this is going to create the option fig for us right here. So just go to line 182. So be on this line, just anywhere on it, and just hit, if you're on a PC, Control Enter, or on a Mac, Command Enter. Do you see fig up there? Did fig appear right there in the top right corner? So did fig appear in the top right corner? Did that appear? Yes or no on that? So I'll repeat the process again. Go to line 182 and hit Control Enter or Command Enter. That's a yes, this current question, right? Let me go to timestamps on here. I can't tell if that was this current question. You might have to repeat the answer if it worked. I think it did. I just want to make sure that I don't go too faster. So we should see fig, and I'll repeat the process again. Go to line 182 and just hit Control or Command Enter. No, it didn't show up. Okay, so what did it say down here on the bottom? What does it say down here on the bottom? Can you send me a screenshot in the Discord of what it shows? Oh, you're showing right here. And if this is a current, oh, that's the previous messages. Let me go here. If you can send me a screenshot of what you currently see, like especially if it has the error message, I can diagnose from there. So if you send a screenshot, let me see. There's another message here. The installation failed. Oh, wow. Oh my gosh, Discord just crashed on me. Discord, what? Wow. Don't usually see. I don't want to connect to Sony PlayStation Network. Let me take a look. Okay, here it is. Okay. Object fig not found. It looks like more is being run. Oh, you need to. Okay, wait. So down here at the bottom, Abigail, where it says your screen might be saying, right, do you want to install packages which need compilation? You want to type capital YES down there in the prompt. Does that make sense? Abigail, right now yours has a prompt like, do you want to install da 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 da? And then you just type right here, capital like that. Does that make sense? Yours is prompting you for a response right now. And it says, do you want to install from compilation? And so that's why it's saying chunks are waiting to be executed, it looks like. You did that? Okay, send me a current screenshot of what you see now. And we'll take a look now. Send me the update screenshot. I'm gonna. Okay. Oops. Oh no. Oh, try. Oops. Misspelled error. Okay. Try. Send me a screenshot of what you see now, and we'll take a look from there. Or you know what? It's still loading. Abigail, you know what? If you are free, I'm gonna, since like I don't expect students to talk to me on stream. Would you, if you want, just tell me which way. Would you want to hop on stream and you can screen share on the Discord, or I can go to my like title screen and I could talk to you on the Discord since it's such, like this chill. I can share with you on Discord and go to just like a blank screen where we'll just hear the UT intro music. Or I can talk to you on the Discord and you would talk on stream. I'm good with whatever. If you want to like me go to the blank screen, I can just hop over to the Discord and I can take a look. Like if you screen share with me, which sounds best for you, Abigail, if you want to go that way, because I think the screen share might just make it really easy for me to see what's going on, and I can be like, oh, click here, and I think we'll get it solved in probably a minute or two. But I can go to the blank screen really easy, and then just like call you on the Discord and be like, oh, let's take a look. So what sounds best for you? Doesn't matter. You know what? Since I'm just gonna hop to a blank screen, so let's do that real quick right here. And you might hear the music when I make the call, so you'll hear us in just a moment. I'll be calling, so check out the Discord. Here we go. We are back. Alonzo, great to see you here. Alonzo, let's throw some points. We were just doing some work, getting some code fixed up. Alonzo, if you got questions, let us know. We got the graphic working. We may talk some more Plotly stuff. Really just, it's interesting. It's I can help out pretty well online, but definitely like just seeing someone's screen can make all the difference. Like if I'm like, oh, click this, do this, it can just be done in moments. So if you have questions right now, let us know. Let's see. Might have. So Alonzo, hopefully you're still here. We're just jumping over the Discord real quick. And let's see if there's anything else on the Discord. People posting help is really great. Yep, illegal. Oh, I love it. I love it. That's Adam Spanbar is throwing some great help on the Discord. We'll see what people are saying. I might code. I've been working on chapter 2 homework and been using Excel. Is that okay? Definitely, Alonzo. Definitely. Do you want some help with chapter 2? Do you have a question you're working on? That is 100% all right. We'll throw some more points, Alonzo, right there. Do you want to go over some chapter 2 stuff? Yeah, no, that's totally fine. Stats is stats. We are here to practice learning statistics. And do you want to talk about some chapter 2? I'm getting my Pearson loaded up right now. If we want to do some chapter 2. And the chapter 2 has stuff like the mean, the median, the IQR. We'll be handling a lot of that very soon tomorrow in class. And we got all those assignments. I'm learning so as I go. But yeah, well, let's take a look at some of those problems because I know people are generally have questions on them. They're kind of tougher. Let's go check that out. Okay, so we are loading it up. Let's go to the chapter 2 homework. Let's do all of chapter 2 homework. Why not? Okay, all of chapter 2 homework. Okay, so chapter 2 homework, stat 201, and let's review the concepts. Here we go, 28. Stat 201, chapter 2, question 1. Let's go check it out. So both classes pretty much got exactly to this point. We just kind of lightly mentioned in the second class the stem and leaf. The first class got to hear a little bit more about stem and leaf. We went into a little more detail. But a stem and leaf is a display of univariate quantitative data. You'll see it up there in the top right, top left corner, stem and leaf, one quantitative variable. And this is a very important graphic to see and to understand the quadrants on it. It's color-coded, as you can tell, where blue is quantitative and green is categorical. I don't know my colors. And then the blacks are kind of like bivariate. Like the black coloring right there means it's a categorical quantitative combination. And there's things we don't cover in this class, like logistic. So the different colors right here, the blue, the green, the black, are going to be different types of graphics we use based on the variable type. Very important to know your variable type. So a stem and leaf is a univariate, only one variable being analyzed, quantitative display of data. So when you look at this right here, we were asking, how many home runs did Mark McGwire hit in a season? Baseball stats. And we have right here a stem and leaf. Now, did he hit 1 home run in this season? Did he hit 7 in that season? Well, let me ask this first off. This is just a number line representing the leading number. There's a key over here that says 7-1 equals 71. So what does this 5 represent? There's like 505, but what does this 5 represent? It represents a season where Mark McGwire did what? That represents a season where Mark McGwire did what? Or you can just tell me the number and I'll explain the rest. But what would that 5 represent right there? 55 home runs. Alonzo, great job. More points in the chat. So Mark McGwire hit 55 home runs in that season. He hit 50 in this one, 49, 44, 44, 40. Each of these digits right here is an observation. We could basically do the same thing if we just drew a histogram. And it's important to know this, that a histogram has bins that collect the data. But a stem and leaf, where you have the number line right here, like 10, 20, 30, 40, there's different numbers, but the stem and leaf would actually show you the observation, like this is 14, this is 22, this is 24, this is 31, 35, 37, 41, 48, and this would be 57. So the stem and leaf actually shows you the number, and so you don't get to see the bins on it, and that's the difference. So this is kind of a key thing to see right here. Here's a histogram, and if we remove the histogram, we get the stem and we can show the stem and leaf. So a histogram is just like where you don't see the numbers. The stem and leaf is where you see it. So histogram would not show you the numbers. and a stem and leaf is going to show you the actual observation. So a stem and leaf would show you that, where a histogram would not. So we know what the stem and leaf is. It's just like the histogram right here, and it's actually showing us the numbers. You can just put bins on top of these. So what do these words mean right here? Uniform, unimodal, and bimodal. Well, it's important to break down the words. Uni, bi have meanings to them. So the idea of uni and bi, yeah, exactly. I try to go pretty in depth on these things and try to make, yeah, exactly. It's more in depth. Like the stem and leaf gives you more information. Great job right there. Bi means two. You got this. I'm throwing 100 points. You're following along perfectly. Such as two peaks. Yeah. So modal is kind of like peak. And then the bi means two, where the uni means one. So we got a lot to break down right here in different parts of the words. So modal means peaks, and bi and uni mean one or two, respectively. And then uniform means it looks like one form. That's what a uniform looks like. Bimodal has two peaks, and unimodal has one peak. So that's what unimodal looks like, one peak. What uniform means, basically one flat, same distribution. Alonzo, great job following along. Perfect. Yep. One flat distribution. It's very easy to actually create a uniform distribution inside of R. You could just say, make a histogram of the numbers 1 through 100, and that is what a uniform distribution looks like. Where a unimodal distribution would look like R norm, 100 random normal digits, and we'll go even more to make it look even more unimodal. But this is uniform versus unimodal. So one flat form and also one modal area. So that's the difference between unimodal, one modal area, one area concentration, or uniform, one flat distribution. We can see them right here in practice too. So this one is very clearly unimodal. You can see the one peak to it. They've just done it upright. So unimodal. One flat form. Should I use R, Excel, or Jump for all the classes? Is it up to me? It's up to you. My top, if you really like data science, I would suggest R. I'll put it this way. I've had students get the highest of grades with anything. So my best suggestion would be use what you're most comfortable with. My second best suggestion is if you're into data science, I would use R. My third best suggestion would be if you don't like data science and you just want to have a good number crunching thing, use Jump. But also Excel is everywhere. There's an argument to be made for each, but use what's best for you. So don't worry, you can excel with any of them. You will need Jump for some of the projects though, but I do accept if people can do the work in Excel or R. I'll use R. Oh, great, Alonzo. Awesome. I'll use R. Do you have R on your computer already, Alonzo? I'll show you how to do everything in R. You see this data set right here? Watch this, Alonzo. That data set right here, since you're here, we can talk about it. You ready? If we go here and type home runs, and then we create a vector and go 71, 50, and if you understand it this way, you have a very good understanding of it. Do you see how I'm writing all the numbers for the home runs? I'm recording all the data. And I'm translating the data points into the actual observations. I wish I could just copy it. Okay. So there it is right there, Alonzo. And let me copy this vector for you. There you go. So there's the vector being stored into R. I'll clear my global environment. But we can actually create the distribution now of the stem and leaf by going here to stem of home runs. And there's the stem and leaf. And you can actually tell it's got a little bit of a skew to the left side. I don't know. Let's look at the histogram of it. You can just literally change the code to hist. It's kind of, it just depends on how you draw it. That's the problem with drawing things is depending on how you draw it. And I don't like how R does groups of like joining things together with stem and leaf. I don't like how R makes stem and leaves. But there's the histogram right here, and we could easily find things. R is you can find things like that very quickly on information. Like I've just found the mean, the median. If you want to find the standard deviation of this, there we go. I'm just copy pasting my code right there to find the values. So that's why I really like using R. You can also do it inside of Jump simply by recording the values like we recorded. And you would just go over here. And once you record the values, like if you go in here and write the values inside of Jump, I'm pretending I'm writing the values now. After you do the values, you can go to Analyze Distribution. I'll pause right here. That means concatenate. That makes it a vector. So, and feel free to ask those questions. And this would do it inside jump. So if you want, if you have jump, you can write down the values inside of jump and then use Analyze Distribution. Get some lag? No, try refreshing the page. It should refresh and should work. Let's hope. We haven't had much lag lately, so hopefully we're good. Not too much lag. Inside of R right here, the C stands for concatenate. It's turning these into a vector of data. So when you say concatenate right here, it joins together the values. Does that make sense, Alonzo? So inside of R, the function C, it's a very simple function that says kind of put these things into a vector. So I'm saying make a vector of these values. That's what I'm telling it, and then store it into home runs. So I'm creating the object home runs, which has the vector information of these values. Always try to explain your code like as a sentence, like create a vector of these values, right? And store it into the object home runs, and then give me the stem and leaf and all that good stuff. So the key concepts we need to know, especially for 2-1, so don't freak out 2-1, don't worry, we got this, is what way is this skewed? Now, the easiest way to understand skew, so here's a big concept. It's time for concept time, one of those teaching to the test moments. So we have here, yep, that's exactly it, Alonzo. And so what we have right here is right to the high, left to the low, whatever way the tail goes. And what do I mean by this? Well, take a look at this data. The monster man is this dude. Here's your little monster man. And sometimes it's harder to tell. There's monster man right there. There's his tail. And so here's the low side of data. And here's the high side. Right to the high, left to the low. Awesome, you understand it. So which one of these is right skew? Is graphic number 1 or graphic number 2 right skew? Right to the high, left to the low. I'm interested in the code. Oh, yeah, we'll do the code right here, definitely. Oh, and I'll show you a really good way to know skewness of this with code. So I'm going to show you how to find out skew with code right here, Alonzo. So I'm going to show you all the code. You're here. You get to ask all the questions. So left is small and right is larger, like on a graph. So right skew is going to be where it's generally pulled out to the high side. So number 2 is right skew. And because right to the high is tails pulled to the right. Top is, so the bottom one is, the top one's going to be left skew, left to the low side, whatever way his tail goes. So left to the low, right to the high. So left to the low, right to the high, whatever way the tail goes. And so this one up here has left skew to it. And this one here has right skew. Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. So that's one of the better ways I've thought to memorize it is right to the high. Let's write that up here. Right to the up, yep, right to the high, left to the low, whatever way the tail goes. So write that right here so people can write down. Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. Good way to memorize it right there. Take a screenshot or practice this, and just one of those things we try to memorize. Right to the high, left to the low being low numbers, high being high numbers, left being the lower side. Yeah, let's do it. We'll get it all right. We'll get them all right. This one's a bit weird, and if you've saved your data into R, we can take an analysis of it. Do I have skewness loaded up? I don't. You will probably have to load up the E1071 library. So if I go too quickly, let me know. This is the coding side of it. I'm doing a full analysis. You'll have to run this code right here and the following code in your R script. I'm going to copy these in the chat for you anytime, and we'll get the full homework done here. Talking through in a more advanced way too, which is neat. So skewness, there it is. So the function, let me just show that. The function exists in the E1071 library. So by loading up the E1071 library, I can access the function skewness, which actually gives you a value of skewness. And this is almost perfectly symmetric, which is going to drive me nuts because I'm trying to remember what it says the skewness of this is. If the skewness is 0, that means perfectly about symmetric data. Negative means left skew, positive means right skew. So this data set is pretty symmetric, it's saying. Where did you open the library from? So running this code right here, just make sure you have it installed. I'll drop in the chat again. You have to install it, or is like Python use a turtle function to draw? We don't use the turtle function to draw. I've done only a little bit of Python. We can tell it to make the histogram here. This is downloading the library. This is opening it. This is when you, what is it called in Python? I know the name. Oh, I cannot think of it. Python uses like pandas is a what in Python, like pandas and the other things it uses. Pandas is called a what in Python. I know it. Pandas is how a lot of people do the stats stuff in Python, like with tables and stuff. I can't remember what Python calls that again. Once you say it, I'll be like, oh yeah, that's what it calls it. I don't do a ton of Python, a little bit of Python. So this gives us access to the function skewness. Does that make sense, Alonzo? So skewness right here is a function that analyzes the skewness of data and returns back a metric of skewness. It's just a bunch of stats that people ran. We don't have to do it by hand. But what does this mean? This means that it is basically symmetric. If you were to take a data set, not that deep into Python just a bit, oh, no worries. How's everything going right here? So this is going to tell us the skewness of the data. Like if we had data that looks like this. So Alonzo, I want you to tell me, how does this data look right here? Is this right or left skew? So this right here is something, if you're worried 201, this is what we'd expect you to know very quickly. Is this right or left skew? Is that right or left skew? Is that data right there right or left skew? So that's what we'd expect you to know. Not how to code it, but we'd expect you to know, is this graphic behind me right or left skewed? Is that right or left skewed? You should know that like, boom, right. Nope, don't. It's where we want you to be really quick and be like, right to the high, left to the low, whatever way the tail goes. So is that one right or left skew, Alonzo? What do you think? It's definitely right skewed. So if we do skewness here, we're going to get a very positive number. Since it's right skew, skewness being left skew will have negative numbers. Skewness being right skew will have positive numbers. And skewness that is non-existent will give us a 0 for symmetric distributions. Notice how that's a positive number, 1.96. Ha, you're funny, stats. If you're a stats person, that'll be funny. It's a big number of statistics. But we just got that kind of randomly. It's closer to 2. So this is a very right skew distribution. What is very skewed? Maybe over 1. But it is right skew by the positive number. What we need to know for 201 for this question is we need to look at this and say, is it right skew or left skew? I'm going to go a little bit of left skew because of this tail. Oh, no, that was different data. Correct. That was different data. That was randomly generated data from an exponential distribution. This function right here, R exponential, generates how many numbers? It generates random exponential numbers. And I told it to generate 1,000 random exponential numbers. So if you just run this portion of this function, that creates 1,000 random exponential numbers. So I'm just creating random numbers there. And they're from an exponential distribution, so you can see some of them are very large. And exponential distributions have a skewness to them. I think it is left skew, and it's barely left skew. Why is it barely left skew? This tail goes a little bit to the low side. Barely. The center of the distribution is going to be about where the modal area is. The 30s or the 40s. Not too bad here. And yeah. And then do we see anything? Oh, we have to know the numbers now. So we just have to be able to read it. Remember, the leading digit is going to be the first one here. And this is the second one. So this is a season with 7, 13, 21, 26. If you're able to, yeah. Does that, here, I'll put it in the chat for you, Alonzo. Here it is right here. There's the code in the chat. Keep asking for those codes. And great job, Alonzo. I always like people like going the extra mile and trying to think like how to code and stuff. 7 was his lowest season and 71. And you can do your project, like whatever works best for you. If this is too much, exactly 7 through 71 is the range of the data. Is there anything unusual? There's a gap. I don't think there's anything unusual. It's not. We look for gaps and outliers. I would say it's 71. I'm going with that. I think it is the answer, right? That's pretty unusual. 71's a lot. His second best season was 55 home runs. 71, there's a gap. And so gap is a key word. Gaps usually lead to outliers if there's a big enough gap. And it likes it. Good stuff. It's kind of unusual. It is a little unusual. So now that is the first question out of the way, and we'll do some more coding right here. You bet. The gap leading to outliers. Key terms we should know when we talk about the shape, the center, and the spread of the distribution. Excellent work, Alonzo. Stat Tool 1, Chapter 2, Question 2. Very unusual. I agree. And so now we have a dot plot. Here's the thing you should know for Tool 1. Dot plots are a way to visualize univariate quantitative data. Once again, we talk about what should go on note cards. Dot plots are a way to visualize univariate quantitative data. So you're seeing univariate quantitative data, how many hurricanes happened over the last 14-year period. So what you could do, and I'll show us how to do this in JMP and in R. So what you can do right here is you can take your data, copy to the clipboard, and we see a long vector of information. I'm hitting Control C now. So I copy to the clipboard, hit Control C, and hit Done. Now I'm going to go over here to JMP and go inside of JMP and anywhere go to File, New, Data Table. File, New, Data Table. With File, New, Data Table, we're going to open up a new data table. Let's check it out. And then we're going to hit Control V. This is going to paste the data inside of here. Now, when you paste, make sure if it's quantitative, it's blue. Sometimes when you paste, you'll actually have to do Control V. Exactly. Alonzo, excellent work keeping up right here. And we'll do this inside of R too. I'll show the way to do it inside of R. You want to do paste this time, but sometimes you have to paste with column names. Watch out if it has a column name, which this one didn't, you want to paste with column names. You'll see me do that in some examples later in the class. Just see if the data doesn't have a column name, like you can tell when you look at it. What do I mean by column name? When you look at the data, copy to clipboard, there's no name up here. It doesn't say like hurricanes or something. If it had a column name, we'd need to do paste with column names. So we can make a dot plot or a histogram. A histogram and a dot plot are basically the same thing, but instead of seeing bars, you see dots. And go to Analyze, go to Distribution. Pause here on the screen. Analyze Distribution. We can double click the column 1 and click OK. And there it is. Looks pretty unimodal. 1 minute. I'm at work. Oh, no worries, no worries. Tell me to slow down or ask a question. I'll make sure to stop and slow down. This right here, and if we're doing a project, we probably want to add in the extra. So when you're doing a project, add in the count access, and we can see how many observations are in each group. So here we are. And the thing is, you might say this is not a dot plot. Well, if it was a dot plot, the only difference would be dots. That would be the only difference right here if it was a dot plot. So we can also kind of trace it and see which one it looks like. Oh, there we go right here. It's a very unimodal symmetric distribution. You can see here that 2, because this bin contains 2, there's 1, 2, there should be 4 observations at 2. 1, 2, 3, 4. There's the 4 2s, and we got the 3 3s. So, and the 3 1s. But all this data right here confirms that this is the graphic. I'm back. So that is a unimodal distribution. Histograms and dot plots can display the same data. Awesome, Alonzo. So the big thing to know, and we're kind of going some learning concepts too on this, is that histograms, dot plots, and stem and leaves, which we can make right here, they can all display unimodal quantitative. I counted them and did that. Yep, you can just count them too. That's another way. It's like pretty not too crazy of a question, but we see here stem and leaves, dot plots, and histograms. So if the big concept right here also to know would be stem and leaf, dot plots, and histograms are all ways to display unimodal quantitative data. Also box plots, which you see right there, there's a box plot. So we got a lot of concepts. We're just making sure we know and understand. Check the answer. We got it. And now we have what is the shape of the distribution. Remember earlier we talked about what a unimodal, that is skewness. We talked about what uniform means, what unimodal means, and what bimodal means. Uniform is one flat form, bimodal 2 peaks, and unimodal 1 peak. So just break down the words as we've done right there on the screen. Unimodal is used for one quantitative variable, but univariate means one variable is being analyzed. So I'm going to show you something interesting right here. Let me go to a data set. And if I do the following, that's our TikTok data that we were sent. If I go to the following data set and check this out, you ready? Analyze fit y by x. Let's go to how many carats a diamond has by its price. Oh, price should explain carats rather. And now we get this. And then here we go. So this graphic right here is a bimodal analysis with histograms for each variable, leading to two histograms because there's two variables. There's caret and price. So we get a histogram for each variable analyzed. But we also see this scatter plot, which a scatter plot is a bivariate quantitative display. Does that make sense, Alonzo? That's kind of bridging into later topics. But when we say univariate, we mean one variable is being analyzed. Notice how this is just the caret of a diamond. This is just the price of a diamond. And the idea of unimodal, this one might be a little more unimodal because it's got one modal area. But univariate means one variable is being talked about, and unimodal means one area of concentration. No worries. So I'll repeat that again here and just make sure to have the definitions right here. This is a little bit bimodal from a univariate analysis. Bimodal because there's an area of concentration here and an area of concentration here. So we see kind of two concentrated areas. And this is from one variable, making this a univariate analysis of caret. This is just only the caret data. Where this distribution right here is more unimodal. There's a strong peak at the start of the data, and this is only the analysis of price, making it a univariate analysis. Now, this inner graphic right here is a bivariate analysis, giving us the relationship between price and caret, and we call this a scatter plot. Scatter plots are bivariate quantitative relationships. So when we say univariate, we're talking about how many variables are being analyzed. And when we say modality, we're talking about concentrations of data. Modality, concentrations of data. Bimodal, and the one up there at top is unimodal. When we talk about univariate versus bivariate, we're talking about how many questions have we asked. What is the caret of the diamond? What is the price of the diamond? And if we only look at this right here, what is the caret versus price relationship? So, yeah, exactly. So this is a bivariate analysis. So the bivariate, two variables being looked at. So that's what we mean by bivariate. So always break down the words. Good practice, Alonzo. And those are key terms to understand. Like when someone says bivariate, they have an X and a Y variable. If you say multivariate, then usually we're saying there's like 3-4 variables. Can I go grab that? Student sent me a really cool multivariate analysis. Did they just send the video of it? Let me actually download the video. Where is it? Student sent such a cool. Here it is right here. Can I download? Let me just. Oh, it's Reddit. Reddit. So good. Let me go see. Sure. Okay. And so this is a multivariate analysis. Okay. So this is a is it going to run? Yeah, here it is. This is a multivariate analysis. I don't think they have a copyright claim on this. But this has in here, John, great to see you. Activity one stream. Yeah. Oh, we'll go check that out here next. But notice here we have the market cap by the size of the dot. We have the different industries something ends in. And these is actually a quantitative analysis right here by industry, by market cap, and by different groups right here by company. So you're seeing so many variables being analyzed, but this is a big multivariate analysis right here. I guess it's change in stock over current year. And you can see which industries have the most variation. Ooh, energy is that how much money people are making? Energy is doing really well. Real estate's dropping. That's really great. So this is what we would call a multivariate analysis. There's more than two variables being analyzed here. The Y variable of interest is whatever that change thing is. I don't know what it is. If they put it on both sides, pretty nice of them to do two axes right there. And then you've got industry, and then you've got each group. You can see like Microsoft apparently dropped, Google dropped, Amazon dropped. Oh yeah. And this is also a time series analysis too. It's got a time series analysis. I actually created a graphic very similar to this using R. Like you can do this kind of stuff in R pretty quickly. So I'll mention that right here, and then we'll finish off the assignment pretty quickly. And then John will do your question next. You got it. John, drop that question. There's one I couldn't figure out. John, drop that question in the chat. We'll do it next. But this is kind of the data is beautiful. Such a cool site. Let me see. I'll show you what we can do with R. And so thank you to my student who sent that in. Data is beautiful is such a cool thing. If you want, you can always give yourself some of the extra roles, and you can see what we're talking about in the coding classes. And so I put this in the R code channel, and you're always free to post in the R code help. Let me see right here. Where did I post it? I thought. Let me see right here. And okay, here we go. I can't find the code right now for it, but this is a graphic I created inside of R right here. So this is very similar. It doesn't look as pretty as theirs. I'm sorry. You bet. Let's do it here next. This is created inside of R Studio. So this has the life expectancy of a country based on its GDP per capita. And so you can see all the very similar sort of ideas. Does that make sense? I go full screen. There we go. So GDP per capita, and you can see over time with different years, countries moving in like modernization, and just some countries really jumping up right here. Like if you watch the very start, watch it one more time. I can't remember which country this is, but you see a jump right here in that country. Like, woo, life will drop down and then jump up. Very interesting to see the continents right here. So we've got a variable continent. It's mainly a scatter plot right here with a time variable. So 1 variable, 2 variable, 3 variable, 4 variable, 5 variable, and then a population density size of how big the population is. So this is another big multivariate analysis, but this mostly is a scatter plot. It's a scatter plot because it's 2 quantitative variables with kind of some other multivariate analysis on top of it. But this is a scatter plot over time with more multivariate analysis on it. But that's the kind of cool things we can do with data analytics. And I made that graphic. I took the code, someone posted it, and then I ran it inside of R. So that can be created inside of R. You can do cool things with JMP too. Okay. So understanding those concepts is really what we're going for. And yeah, Alonzo, I think it's super cool. It's what excites me. We're having more chill office hours lately. Jump in here and ask questions because we're going to do John's next. And I think I need to look at my schedule. My phone's over in the other room, I think. So I don't have it next to me to remind me and go bling when my things are coming up. We're still going. We're fine. Office hours technically over, but we're going to keep going. The distribution is unimodal, which means it has one peak area. Is it skewed? No, it's very symmetric. It's got that symmetry to it. And so I'm going to kind of speed run the next 2 questions. And that's, and which of the following best describes the center? Now, this is a key concept right here. If the data, I'm going to write this out so people can see it. And so, John, there's good practice here too, John. So if the data is normal, center, spread, if the data is skewed or has outliers, this is key stuff to know for Stats 1. John, can you enter any and remember any of this? Or because this is going to be, I think you're in 320, right? So yeah, this is going to be in 320. We'll be covering this very soon. These topics come back. Oh, great job. So if it is skewed, the center will be the median and the spread will be the IQR. If it's normal, it'll be the mean. And if it's the spread will be the standard deviation. So these are key things we need to know. And it's important to know that center and spread are either mean or median. Center or spread are either mean or median, where we use measures of center is either mean or median, where spread is either standard deviation or IQR. IQR standing for interquartile range, and the standard deviation being a standard distance from the mean. Great chart right there. So make sure you know this, that measures of center are mean or median that we generally use, and the measure of spreads are standard deviation and IQR. There's other ones, but those are the ones we generally use. And let's finish off. We're going to hop to John's question here in a moment. So this data set, it looks normal, like it looks not skewed. It's very symmetric. So since it looks very symmetric, the best measure of center is going to be the mean, and that's about at 3, because you can see, oh, it's not. It's at 2. It's about at 2. It's going to be symmetric around that. Like you average those up. You could check, but it's symmetric, so it'll average towards that. The data goes from, I believe, 0 hurricanes to 4. Yep. And that's got it. Any unusual features? No. It's just normal looking data. This one right here with the 11 bowl games. Now, this is one where we're going to use JMP, and so John will do it here in just a few moments. I'm going to do this one a little bit quickly, but follow the steps. We don't do a lot of things by hand. So the median is the middle number. The median is the middle number. And you know, we can actually just find this by going to the data. Let's go to copy to clipboard, and we're just going to hit Control-C. Notice there's no column name. And then we're going to go in here and go to JMP. And with JMP, we're just going to click around. We're going to go to File, New, Data Table. So now we're just going to put the data in so we can see it. Boop. And we're going to pretend we're taking a test right now. Probably one of the good things to do is like, well, how would we ask you this on the test? Well, if we paste the data with Control V, it's like we've written down the numbers. But the first thing we want to do to find the middle number is this. Write this down. Put the numbers in order. Now, it would be a lot of work if we're doing this. So let's say right here, to find the median, 1, put the numbers in order. 2, if there is a middle number, it's the median. 3, if there is not, average the two middle numbers. Let's put a side note. Position of middle number is n plus 1 divided by 2. I'll talk about that here in a second, but the position of the middle number can be found by doing n plus 1 divided by 2. I didn't think so. Would you mind working through it in R? Oh, yeah, let's see. I'll do it in R2. And then, John, don't worry, John. I'm going to make sure we stay here today and we do your question. How many of us have a distance of Yes. I'll show that here. So, John, it'll be in the video in case you have to leave. So right here, let's look at it inside of jump, and then we'll swing back and do it in R right here. And I need to put a timestamp for this one. So this was about 101 to 201, chapter 2. I like going in depth on these questions, like the deeper understanding. So if we have these numbers right here, we can click up here and go to sort and go into descending. I like ascending. I like looking this way. And now the middle number is 39. So the middle number right here is 39. And with the middle number being 39, that's the answer. Now, if you look at the formula I wrote, n plus 1 divided by 2, oh, that's awesome. We're definitely going to do it. So 11 plus 1 divided by 2. The middle number is the sixth number. So that is the middle number. So 39. There we go. Check answer. We're good. Now find the quartiles. Now this is easy if we do it here, but we never ask this on a test. If you look at when I divide the data like this, do you notice how there's two numbers here, two numbers here, two numbers here? So if you put the numbers in order with this data set only, you kind of have the lower region and the upper region, and this is the middle number here, and this is the middle number here. I'm going to show you how to do this in R in a moment, and it's pretty interesting because we're going to see something pretty kind of drives me nuts about this problem. So there's the numbers. I also think when you do this problem, if you get the other version of it, oh, that was it. Let's go look at it. Okay, so how to do this inside of R. So doing this inside of R, we need to first create a what, Alonzo? So what do you think we should create? And here's a hint up here. What do you think we should create inside of R to store the data? What is this called again when I put the points in? John, this is good practice right here. So John or Alonzo, let's throw some points out to both of you. What should we create inside of R to put this data inside of it? We should create a what with the values. Kind of a data set, kind of. You could actually create a data set. We want to create like a vector, and that vector could be stored into a data frame, but we're going to create kind of the vector of data. Now, I've still got it stored into my storage, but watch this. I'm just going to call it data, left arrow, and open this. Now, great job, John, right there, more points. So this is a really interesting way. With the smaller data set right here, I'll show you kind of the quicker way, but there's a quick way to do it I found out a while ago. I'm going to paste the data, but what am I missing right here between all the values? What do you notice I'm missing that I should put between all the values? Because they're different arguments inside of what I'm turning into a vector. And I could like delete the spaces to make it look more like normal, but there's actually a trick I might use. What am I missing between all the values? Yep, vector, yep, stored into the object data. This will be a vector stored into the object data. What am I missing between all my values? Look up here at the one I created, commas, exactly. So you could just go and do this right here, completed. But there's a shortcut, especially for data that's very long. I think it's Control-Shift, and then you scroll up. That's not it. Is it Control-Alt-Shift? There it is. Alt-Shift allows you to repeat an action on multiple lines. I spent quite a while trying to figure that out. I don't know if it works the same on a Mac. I think it does. I think I've done it on a Mac, but you could just put all the commas. But I'm using Alt-Shift to repeat an action on multiple lines. You could just write all the commas if you want for this one. But if you have like thousands of lines, Alt-Shift and scroll up, and it helps. So we now have the data vector, and it's stored in here. So we have the 11 values. Now this is what's interesting. The function quantile of data will give us different numbers. And I have to remember, what type we are using. So this is what drives me absolutely crazy. And if you think the answers are wrong inside of your thing, if you use jump or something that gives you answers that don't match, just let me know. The way people compute the quantiles is up for dispute. There's different types or different ways that people figure out these quantile numbers. So people have disagreements on these. This is like very in-depth stats, like different equations people use to figure this out. So I always forget what type we use in our class. If we go to type equals 5, you'll notice the numbers change. And those are not our numbers. We got whole numbers. I think we just figured out it might be type equals 6. And 38 and 53, there it is. So type 6, that's another argument there to tell the type we're doing. And that will achieve the same answers. And so now we have the quantiles of the data set. And there you go with type 6. But the original type it does by default, which we could look at which type it does by default. I can't remember off the top of my head. Type 7. It does type 7. This is the default argument it uses. Does this make sense here, Alonzo? Tell me your thoughts on this. And I'm so glad you want to see this R stuff. John will probably tell you this will have you way ahead of the game if you're coding it for when if you go to 320. But if you take upper level classes or you use it in any sort of major, like some classes, a lot of classes are using R these days. I have students come in, they're like, oh, I'm in ecology major and I'm using R. I'm like, yes, nice. So it'll help you out through a lot of majors and understanding how to do the code and what it's analyzing for you. So this right here. And so John, check this out. You ready? So if we wanted to see in the data set how many of them are equals to John, quick hint right here. Let's say we go to the data and we want to see how many are equal to 38. We could do the following. Does that make sense, John? Kind of a quick hint right there. If you have a vector of data, you could check to see if things are equal to it, and you could add up the trues and falses, and that's how many values are 38 in that data set right there. So if you wanted to see like how many of those values in that data set are equal to 38 or 999 or something, you could check the vector to see if it's logically equal to that and then sum up the trues. Trues and falses are ones and zeros inside of R. So John, let me know if that helps. We'll probably circle back and look at that here in a moment. But hopefully that kind of shows how to do a logical check to see the amount of observations that meet a condition. But no, good stuff right there. And John, we'll circle back and maybe we'll go more in depth on that. I think we're on the last question on the homework. Sort of similar stuff right here, dealing with 5-number summary and stuff. Let's write down here the timestamp. So stat tool 1, chapter 2, question 4. And let's take a look right here. So guess what we're going to do? We're going to take the data again and go over here to copy to clipboard. And I'm going to show this the non-R way first, and then we can talk more about R, but you might be figuring these things out right here. I'm going to copy the data. And I'm going to bring it over to Jump, or you could bring it to Excel. Now remember, once you go to File, New, Data Table, remember if it had column names or not. This one, like the others, has not had column names today. There was no name at the top telling us what kind of data it is. We'll just go Control-V, and we've pasted it. So the first step, once again, is always to order the data. When you are finding the median with your data, put the numbers in order. So let's put the numbers in order right here by just going to right-click here and go to Sort. And I like to do ascending order, going from lowest to highest, right? There we go. Now, with 10 numbers, the equation I put on the screen right here shows you how to find the position of the middle number. How many numbers do you have? Plus 1 divided by 2. So we have 10 numbers right here, plus 1 divided by 2, and the position of the middle number will be right here. So what should we do with those two numbers, Alonzo? We've got here 650 and 900. To find the median, find the what of those numbers. So just take a moment right here. Just think through. We haven't played any music today. We should do what to those two numbers to find the median. Like, let's find the median right there. There is no middle number here. So if there is no middle number, the median will be the what of those two numbers. With 10 numbers, we say 10 plus 1 divided by 2, and that's position of the median, which we're showing. It's right here at the 5.5. And that's a position. That's not the value of the median. It's just the 5.5 number is the median. So to find the median, we add them together and we divide by 2 exactly. So we're going to take the average of these numbers. There we go. And that's got it. Add them together, divide by 2. You got it, Alonzo. More points, 100 points. Alonzo, I appreciate you being here asking all these questions. And, well, that's not the mean. To find the mean, we add up all the numbers and divide by the total. Now, this is where we're not going to do the work ourselves. let's go over here into Jump. Where's my Jump data? And let's go over here to Analyze Tabulate. Analyze Tabulate is a way to just get certain information. With Analyze Tabulate, we're going to take our data and put it right here. And then let's just go to mean of the data and drop it right there. There's the mean. You know what you can also do? You get the standard deviation. Oh, it didn't tell us that. It said no. There we go. There's the standard deviation. Where's the median at? We can confirm the median value. There's the median. And that's the value we just got. You could probably, let's try this. Let's drop the data right here. Mean, standard deviation, median. There you go. Just get the values you want. You're welcome, Alonzo. So Jump's pretty good at this stuff too. You can just get those values pretty quickly right here inside of Jump. And yeah, so now we know the mean is 845, and that's the average of all the values. And there we go. The median we got was 775. We got that a moment ago, the middle number. Q1 is where things get a little bit interesting again. I would suggest looking at your data. We do not ask this on the test. But if you look at the data right here, here we go. You basically have the lower data and the upper data. So which number? Awesome, Alonzo. I'll finish this off right here. Thank you so much, Alonzo. Another 100 points. Appreciate you being here. The lower quantile is going to be at 650. If you look at the lower portion of the data, the third number right here is the middle. If you consider this to only be its own data set, 650 is Q1 right there. And so that's put the numbers in order and find the lower number. Let's go look at the data set again here, but look at it from the higher numbers. And so we might have to do it this way. Let's scroll. Here we go. We almost got it. There we go. So this will be the middle number in the higher portion of the data set. So divide the data set into two portions and then find the number. And that's 1050. Check answer. We'll go right there. And then the range of prices, just the lowest number to the highest number. With your data organized, and I like to talk about how we could do it on a test, I'd look at the numbers from the lowest to the highest, and the range is the distance. Those numbers are away. So you take the biggest number and minus the smallest number. So big number minus small number is the range of the data. And we get that right there, and we're good to go. And the IQR stands for the interquartile range. So the interquartile range is a slightly different topic compared to the range. So when you think about the range of the data is going to be the biggest number minus the smallest number. Like imagine test scores go from 40 to 100. This data has a range of 60. So the range here is 60. But the IQR, which stands for the middle 50% of the data, like if we think about 50% of the data is contained within the IQR, which maybe goes from here to here, and these are quarters. So the IQR is the middle 50%. And maybe the IQR starts at 50. It doesn't have to be symmetric. We'll put it down here. 50. And so because we're talking about 55. And goes to 70. All we're asking is what's this value? So the IQR is the range of the middle 50%, where the range is the distance the full data set goes. So visually here, we should think, what is the IQR? Well, the IQR will go from the positions of Q1 to Q3, where the range goes from the minimum to the maximum. And here's where Q1 is, because that's one quarter add up. Here's where Q3 is. And here's the median right here, which is the 50th percentile. So the median would be right here. And the IQR is the range of the middle 50%. In my graphic here, it's 15. The equation for IQR is Q3 minus Q1 equals IQR, where should have done another color on that. The range is max minus min. If you look at these equations right here, you'll notice it's always big number minus small number. And that's how these equations work, is they're just a distance. Like, what is the range? The interquartile range, the range of the middle 50%. Big number minus small number. What is the range of the data? What is the distance between the biggest number and the smallest number? So the interquartile range is just another range, but only considers the range of the middle 50%, which is 50% of the data from Q1 to Q3. And so that is the range of the middle 50% right there. So if we look, we've already figured out Q1 and Q3. And so this is the distance between 25 to 75 is 50% of the data. And we just need to take their distance and do 1050 minus 650. And that is the IQR. That's how far those numbers are apart. And that's got it. I think we did it. A lot of work right there. It's a good review. Basically, we covered a kind of a review of chapter 2 if you went through this. So great job. We sometimes do questions quicker, especially when there's a lot of them. But John, we'll hop right here and we'll do a segment about this. So John, great work. Let's pull up John's question right here. John was saying, around I was on doing X51 when I actually got my answers in the Canvas content, there was one I couldn't figure out. How many individuals have a distance of -9? Remember to use this. Okay. Let's go check this out with code right here. And let's start a new sheet, BAS320. BAS320, activity 1, logical checks. Okay, let's go check this out. Here we go. So we need some data right now. And to use the data, we're going to just use native data inside of R. And there's a data set called mtcars. mtcars is something you'll have because everyone has it. Watch this. I'm just going to remove everything. And this is a data set that just kind of exists. It's like a freeware game on your computer or inside of R. mtcars is just a bunch of cars. If you take a look right here, we'll zoom out a little bit so it all goes on one screen. And let's rerun it. And there it is. Here's the cars. There we go. We got a bunch. We got a Mazda RX-4, Mazda RX-4 WAG. I don't even know what these things are. Datsun. Someone's like, it's a Datsun, not a Datsun, or I don't even know. 710. All these cars right here with different data on them. But imagine you wanted to know how many cars are a, let's say, 6-cylinder car. Well, we need to go to this variable inside the data frame. The data frame is called mtcars. So there's the data frame. And then how do we get to a variable? So hopefully you're screaming something at me right now. I don't know if we have many people watching, but the question is, how do we get to the variables inside the data frame? You're like, oh, $. Dollar signs get us to the variables inside the data frame. Dollar signs connect a data frame to a variable. So now we can actually look at we were talking about the cylinders. We can look at the cylinders. There's the cylinders. So now we just have that one vector. If you think about what we're displaying on the screen, we're only looking at this information. You notice how it starts here, 664686, 664686. So it follows the same pattern. It's just this information right here in this vector, but it's just the one bit of information for us. So then what can we do with this? Well, let's ask a question. Are the cylinders that we see right here, are they equal to, and that's logical equal to 6? Now, be careful. 1 equals means store into. 2 equals means logical equals. So if I did store this, be careful. I don't know if I want to do that. It's going to destroy it if I do it. It will ruin the example. Let's load up the wind. Let's load up the diamonds data set. Okay, so if I have diamonds data, and I'm looking at the price of a diamond, there's the prices of a diamond. And if I want to see if a diamond is equal to $289 here, it's going to tell me. You see that last one is true because that one was equal to it. I used that one because I saw it there and I saw it was equal to that. So it's telling me it does have that price. But be careful, and this is why I'm going to destroy this data set, is now if I do this, I stored that value. This is bad. I just overwrote the data. So this is a logical check to see if it is logically equals to 6. This assigns or saves or equals it, assigns it to the value of 289, 2898. This assigns the value of 2898 to all observations. This would be a bad thing to do, and it would destroy your data. So you're going to show me this on the same data set that I'm working on. I'm pretty sure I messed something up with my code. I'm pretty confused. Message me on Discord, John. We'll take a look because we're basically two right now. You want to know how many individuals or something meet a condition, right? So this right here is a logical check, right? So this does the logical check. And then guess what we can do? If we have a logical check, it gives us trues and falses. True. So do you have something like this? Try coding in those. Little bits. We always code in little bits. Do you have a logical check right now? Like, does it logically, does it show trues and falses? Can you get this right here? So we should have some like trues and falses where we have our vector, and then we're checking to see if it's equal to certain values, and then we can see, it might just say a bunch of falses or something, but it's because probably might not be a lot of them. How are we on this? Do you have like trues and falses? Or at least a bunch of falses, maybe. How's that looking? Good on that. Does this run where you tell it your vector and then you check to see you don't? Okay. So error, unexpected symbol, and mean custody amount. Okay. Unexpected symbol. I got this. Can you send me a screenshot on the Discord right now via a DM? Send me a screenshot, since, you know, like with a lot of assignment stuff, send me a screenshot on the Discord in a DM of the error you're getting, like of your screen. Like go to your snipping tool if you're on a PC or Command Shift 4 and take a full screenshot like this of the code you've currently run, and that'll let me analyze what's going on right there. And so we'll see, because that, well, you're taking the mean of it. Yeah, you can email it. Mm-hmm. Let me go to emails. Good, that's awesome. We got a room booked. And I'm going to check here for all the email. A little chill music right here. Let's see. Yeah, tell me about, I see you're saying the, okay. Oh, you're right arrowing the cust into that. Looks like object cust D was not created. You're right arrowing into cust D, you want a left arrow. And so right now you're right arrowing, and that's storing cust D into the subset. You want to store the subset into cust D. So instead of, like right now you're doing a right arrow, you want a left arrow into it. I don't know how to left arrow. You want a left arrow into it, and then do these things in steps though. So make sure that runs. So if you notice in your global environment, you don't have the object created. So you don't have the cust D created. You want to see the cust D over here, the customer data set, like that we call it cust D. That should be created. And then the mean isn't running. And then you have data equals 9999, but we want to do a logical check. Were you able to get the, Here, I'm going to remove, if you could remove, I can remove things. That way people have to write it out. Even though, like, I basically showed it on stream too. Don't worry, you're fine. So that way, but yeah, so that should work. Does that create the cust D data frame? So does that create the cust D data frame, John? I'm going to email class right here as we're waiting. Does that create it? How are we doing on that? Let's see. I think I'm doing 475 in a moment. Let's go right here to class links. Yep. Class in 22 minutes. Here we go. Announcements. Class in 22 minutes. Bonus for being early. See you soon. Click here. Okay. There we go. Got it. Oh, and I need to go to sections. Section 1. Got it. Save. Good to go. Oh, no, don't worry. Object data not found. Oh, so you don't have a data object store. John, this is, John, 300 points. Don't worry. This is, hey, John, you know what? Do you have a, when you click the Discord link, have you clicked the Discord link and does it let you join? Because you can screen share on the Discord. If you hop on the Discord and message me on the Discord, we could screen share real quick. I'm going to probably go grab some food in a moment. But if you want to hop on the Discord, I can walk through what's going on. Does that work for you, John? Have you ever used Discord before? It's really easy to just like message, drop a picture in. Is that working at all? Or how's that looking, John? So the data object hasn't been created yet. Don't worry, this is all steps, and you're doing the right thing by starting now, because it becomes something where you're like, oh, this is the problem. Like it becomes second nature, like riding a unicycle, which seems impossible at first. And you're like, even a frog can do it. Yeah, try joining it and let me know when you join. I'll add the role to you. So if you join, and then I'll message you, and I might go grab some food real quick, but tell me if you join in. And I see someone just joined at one. If that's you right there. Okay, I think did you just join? I'm on good faith. There, I just messaged you. So I think I did. We'll hope. I think so. I think you joined like within that minute. I can say, just takes a minute. Tell me if that was you. I'm on a limb. We'll see. No, hop off right here when we confirm. We'll hop over to the main screen. We'll talk. Awesome. Do you see my message there on the Discord, John? I messaged you on the Discord. We'll see this message. There you go. I messaged you on the Discord. Says you don't have permission to send a message. I added a role to you. You should see I DM'd you. Do you see the DM? Like in your top left corner of the Discord should show like a DM from me. So do you see like the direct message on the Discord? I'll do a ... Oh, you're typing something. You can see it. Awesome. Okay, I'm going to end the stream. Head over there and we'll talk to you right there. Bye, everybody. Bye. Bye for now. We'll be back. More streaming tomorrow.